Hi everyone, today we'll be going over the one-way slab module in our Australian templates. So if we scroll down, we can find the one-way concrete flat slab under walls and slabs. And pop that open. And the reference we use for this calculator is AS 3600, the 2018 version, Amendment 2. And we list our assumptions here. Just pop open detailed and get into the template itself. So in key properties, we can input our geometry and dimensions. So we can set the depth of the cross-section at midspan, so our typical slab thickness, as well as any present drop panels. So if we set this to 0, then we're defaulting to that no drop panels exist. Then we can set our concrete strength and type, so 32 MPa normal weight, and the total length of the slab. So the length of the slab is the span of the slab, and then the width of the one-way slab. So in this calculator, it is of note that our calculations are done per meter width, and so the width of the slab is for the designer's reference to know how many 1 meter width there are in this particular one-way slab. We'll calculate the total volume, and we can set various supports and types of supports here. And so going on down, we can set our longitudinal reinforcement for the positive moment regions here, and then there is the top and bottom reinforcements. So this portion shows the bottom reinforcements, which are the main resisting reinforcements in a positive bending region, and then our top compression reinforcements. So we can set the bar size, the bar spacing, and the concrete cover. The next section we'll move on to is the transverse shear reinforcement. And these are applied typically at supports, and we can toggle on and off as to whether or not we want to include these. If the slab isn't failing in shear, it might be easiest to just not include them and detail them per the local building code. The cross-sectional dimensions at end supports would affect the support connections. So for a full width wall, we don't do particularly any extra checks, but we will note that if you put in a rectangular column, we will consider a punching shear and punching capacity. And so when setting a column, you can put in the dimensions of the column, and then we'll consider how punching shear, whether or not punching shear is of concern. So let's actually leave that as rectangular column for now. Before we move on to loads, actually I'm just going to note that this is for positive bending. If we note that there is negative bending, such as it's a continuous span slab, the template will also generate cross-sectional dimensions of interior support. So before we only had end supports, now we also have an interior support. You can set this the same as the end support or any of the other options. And then we will also find a section for longitudinal reinforcement at the negative moment regions. So at these regions in the middle, where there's hogging moment. And then in these cases, the critical areas of reinforcement are the top bars, because the slab at this portion is in hogging moment. So all these inputs are basically identical to the positive moment regions. And then similarly, it'll also prompt if you want to add shear reinforcement at the negative moment regions. Next, we can move on to adding loads. So in the load addition, you can add distributed loads or line loads. A distributed load will consider the magnitude of the area times a 1 meter tributary width. So we consider these one-way slabs in strips of 1 meter. And then the line loads are applied actually as line and moment loads into and out of the page, also in considering 1 meter strips. And then here we can set our deflection criteria. So we can set absolute deflection as well as deflection limit per span. Here we can change the climate environment type. So note that this changes the climate environment type changes the factor used for shrinkage and creep. I do want to note that if you're picking coastal or tropical, you might actually also potentially want to reduce the concrete cover in these regions. So, and then the last thing of note is you can also set a maximum slab depth and a minimum beam depth. And then once that's set in the template, we'll double check that the geometry set does not exceed these member properties restrictions. And then the rest of the section lists all the member properties. And then we'll do a load case analysis and a section analysis at the mid-spans. So we'll do bending analysis, punching shear analysis, shrinkage, creep, deflection, as well as a stability analysis. And all of these are the method we use or the clause are listed in the section headers, and all of these results are summarized in the results summary. So we can see here the positive moment, the negative moment, shear demand and capacity, punching shear demand and capacity, because we mentioned that the edges are supported by columns, and then governing short-term deflection, governing long-term deflection, and governing imposed deflection. And that's all for our one-way concrete slab. And of course, if you need help, please feel free to open the help button here, and we'll have all the relevant concrete slab help articles, and you can ask any questions here, and our team of engineers will get back to you. Thanks.